to be acknowledged that all of its members, with their great minds and noble ideas, act as the 14th forerunner of excellence of the organization. That all of the hearts it has transformed unite as the 14th force that propels advancement and change. The collective body of all its members serves as the 14th pillar that upholds the organization's values. And that in essence, the entirety of the organization is UP-SIAM's 14th white stripe. Because in UP-SIAM, we are our own founders.
As a development intern, we were given back-end development training, front-end development training, quality assurance training, and testing. I guess the best part of being an intern here at Twist Resources is that Twist offers a lot of technical trainings to their interns, which I think is very useful once you go out to the industry.
When I first got into Twist, I was really fascinated with the organization culture that it has because the senior manager seems to be very close with everybody, and everybody was very casual, but at the same time, people were productive. So there, I got invited to a workshop, and it's about Agile and Scrum. It's the project methodology, that framework that Twist abides to. So there, I learned a lot about the terms and also the processes that they follow from day to day.
I was really surprised when they invited us to join the Agile meetup because I didn't expect that those were available. And then when they asked us to join and we went there, I was surprised that the setup was collaborative and it wasn't just one speaker in front, and then it was everyone. Everyone could contribute. Even I was so scared to ask the question, but it gave me the opportunity to learn about Agile in a different setting from people that don't know Agile and from people that do.
So here at Twist Resources, even though we are in a work setting, we still have social lives within the company, not only with my co-interns, but also with some full-time employees. Like one time I was absent, the next day there's a lot of people that noticed that I was gone, so I'm not invisible in the company. And conversations range from different things, not only related to work, but our personal lives, so we can connect on different levels.
On November 23, 1976, the UP Circle of Industrial Engineering Majors was established by a group of IE students who perceived the adamant need for an organization that can address their academic needs. 13 brave pioneers had risen to challenge. 13 passionate hearts had united for a single cause. These 13 students have since become vital foundations of the organization. The very emblem of UP SIAM represents them at heart. The 13 founding members. The 13 white stripes. 41 years since its establishment, UP SIAM endures to build on the groundwork laid by its founders. The organization continues to pursue excellence not only for itself but for the entire IE community. Believing in Kaizen or continuous improvement, UP SIAM strives to extend service to society through the best of its means. Each undertaking of the organization only serves to fortify its legacy, and it is only through the strength of its members that UP SIAM continues to rise. It ought to be acknowledged that all of its members, with their great minds and noble ideas, act as the 14th forerunner of excellence of the organization. That all of the hearts it has transformed unite as the 14th force that propels advancement and change. The collective body of all its members serves as the 14th pillar that upholds the organization's values. And that in essence, the entirety of the organization is UP SIAM's 14th white stripe. Because in UP SIAM, we are our own founders.
All right. Good afternoon, everyone. Welcome to day 2 of UP ACM Fest 2021. My name is Lance Lim.
My name is Lance Pineda.
You may recognize us from yesterday's talks, and yes, we will be your hosts again for today. So today we will be oriented on the technical side of computing through workshops and lectures prepared by our acclaimed speakers. But before we hear from those speakers, let us first congratulate the winner of yesterday's question of the day.
So who will be the winner of today's question of the day? Drum roll, please. The winner is Angelo Genesis Talastas. Is this person here? If not, your prize may be now. Thank you for answering the question of the day, and congratulations on your prize. The event organizers will be contacting you soon. So just keep your channels open. Okay. So guys, don't forget, like and follow our Facebook page to get updated when the next question of the day is posted for a chance to win. You guys still have a chance to win, okay? But before we begin, Lance, our sponsors.
Of course, ACM was made possible by our major sponsor, Course Hero. Our ACM Fest sponsors Samsung Electronic Philippines Corporation and Twist Resources. Our media sponsor, Inquirer Pop, and in partnership with People Management of the Philippines.
This event is also in partnership with Ateneo Mathematics Society, ACM Dresden Chapter, ACM FU Alabang Chapter, ACM FUI Tech Chapter, ACM TIPQC Chapter, and ACM Fest was also brought to you by UP Circle of Industrial Engineering Majors for the benefit of Kids for Kids.
So as UPM is united in the objective of inclusive community development, ACM Fest also aims to create a positive impact on the community. With ACM Bayanihan, UP ACM has partnered with Kids for Kids, a nonprofit organization that seeks to empower the youth and to use optimistic action to work towards a world wherein a child's right to a safe environment is lived out every day. UPASM would also like to humbly ask for your support in their efforts to combat online sexual abuse and exploitation of children. A generous donation of any amount would be of great help in supporting this cause. You can send in your donations via the channels posted on your screens, as you can see over here. So in GCash, PNB, BDO, and BPI.
Please take note of the accounts. Have they been noted? They're probably noted by now. So with that, let's get started with our first speaker. But before we begin, we would like everyone to keep in mind that if you have any questions for our first speaker, you can ask them through our Q&A platform. The link will be displayed on the screen above the slides, and it will also be sent on the chat box right about now. Okay, so with that, Lance, can you introduce our first speaker?
Okay. So our first speaker for today is a machine learning engineer at InnoVantage Inc., where she works with the research and development team in developing natural language processing solutions. She formerly worked as a data science engineer at Wave Computing, a startup based in Silicon Valley creating AI applications for computer vision problems. She holds a bachelor's degree in computer science from University of the Philippines, Diliman, and has presented and published a paper entitled UILS, Ischemic Stroke Lesion Segmentation Using TensorFlow UNet in the Intelligent System Conference in London, UK. She formerly worked as a data science engineer at Wave Computing, a startup based in Silicon Valley, creating AI applications for computer vision problems. She holds a bachelor's degree in computer science. Okay. So let us please welcome Miss Abby Del Castillo.
Miss Abby.
Thank you for that intro, Lance. And so let me just share my screen. Mhm. Just give me a minute. Okay, there. Can you see my slides now?
Yes, we can.
Yes, we can.
Okay, thank you. Okay. So, hi everyone. Today I'm going to teach you how you can kickstart your AI projects by building your own prototypes. So, if you're familiar with hackathons, these are competitions where your team is expected to develop an app given a limited time. So, with this talk, I'll share the guidelines you can follow if you're facing a similar situation, wherein you need to have a working prototype as fast as you can. Okay, so first, I just want to give a short intro about myself and how I got into this field. So I started getting into AI back when I was an undergrad. So during my fourth year, I worked on my thesis under the Computer Vision and Machine Intelligence Lab. So it was an image segmentation project, and its main application is isolating stroke lesions from MRI scans. And right after graduation, I joined Wave Computing. So I worked as a data science engineer developing applications for computer vision problems. So I got to work with people from different industries, solving their problems through our tech. And then last year, I joined InnoVantage. As a machine learning engineer, I work with the research and development team on creating NLP solutions for Aya, our e-commerce platform. So the goal now for R&D is to create more AI-powered features to aid our users. Okay, so enough about me. Let's proceed with talking about artificial intelligence. So before we begin, we have to understand what it actually is. So for this, let's do a quick activity to gauge what you know about it. Okay? So tell us, what are the first words that come to mind when you hear the word AI? So guys, ayan, if you could, please scan the QR here and or you could go to slido.com and input this number code so you can submit your answers. So let's just wait for your answers to reflect here in our word cloud. Right? I think maybe We could wait for around a minute if that's okay. And so everyone can participate, whether you're in Zoom or we also have live stream. Am I correct? I think it's through YouTube and Facebook. So for those watching through live stream, feel free to answer as well. Ayan. Okay, so thank you for those two participants who already submitted. And we have 4, 5. Let's just wait for a few more maybe. Okay, you can see a lot of people submitting their answers. Smart robots. Wow, it's already big. Okay, so let's wait for a few more. Yeah, and I think we have around 30 participants here in our Zoom meeting. Oh, neural network. Okay. Sige, I think we have enough. I'll try to read all of your answers later. So here we have smart robots. We also have neural network. I think robots, that's one of the more common concepts associated with AI because of what we see in movies and in other media forms. So what else we have here? So neural network is another big word here because a lot of people answered that. That's correct. So what else we have? Machine learning. We also have Jarvis. Okay, so we have an Iron Man fan here. Skynet, but it's from Terminator. If what else? We have Siri, automation, Mark Zuckerberg, deep fakes. Okay, that's becoming more popular nowadays. So we also have the future, Terminator, Tesla. Okay, di ba? So as you can see here, people have diverse and really interesting thoughts about AI. So which is a good thing because it's easier to grasp new concepts if you already have an idea about it. So thank you guys for participating in our quick activity. So let's proceed with our next topic. Okay, so when I ask the same question to other people, here are the most common answers I get. So number one is robots. We also have machines, and an extreme one is the Terminator, with their goal of what world domination. But as we learn more about AI, you can already say that it's more than just robots and machines. So let's talk about what are these other classifications by knowing its subfields. So you might be wondering, there are several terms being used interchangeably, such as artificial intelligence, machine learning, deep learning, and data science. So here's an overview on how they actually differ from each other. So AI is the big umbrella that is composed of other subfields. So the main idea behind it is allowing machines or our computers to replicate how humans are able to think or act. So this can be done through automation processes, smart devices, and even robotics. Next, we have one of the most popular areas of AI, which is machine learning. So it's a step further because now you're teaching the machine to learn with minimal human supervision. So think of it as the more you use the program, the smarter it gets. So it tries to recognize patterns from your data and use that to make better predictions next time. And then here we have deep learning, which is a subset of machine learning. So what's being used here are more complex neural network models with deeper layers. It's an attempt to mimic the neural networks found in our brains. And data science, on the other hand, involves AI but is also composed of different fields such as data analytics or statistics. So its tools and processes are being used to draw insights and make smarter business decisions based from existing data. So later you'll learn more about these data skills with Richie Upstock, so make sure to attend that. And now to make it more relatable, here are some examples on how we use it in our daily lives. So one example is with voice assistants like Amazon's Alexa. I think I saw Alexa from the word cloud earlier. So what you see here is the Amazon Echo, which uses an AI software. But how does it actually work? What if I ask, Alexa, play Despacito? So the first step is converting human speech into text. So it uses the same concept with the voice assistants in your phones. And if you'll observe, it analyzes each word that you say. So this part is called speech recognition. So once it got the whole phrase or sentence, it tries to identify what you want it to do from a set of predefined or custom intents. So this is where NLP comes in. Through this, Alexa would be able to match it with an intent and perform the necessary task. In this case, it will play the song for you. So all of these happen within a few seconds. So that's how fast the technology is right now. So what about computer vision? So what I'm going to show you next is a short clip from the K-drama Startup. So maybe some of you are familiar with this. Ayun, may nakapanood na ba dyan sa audience natin? So for those who haven't watched this amazing drama yet, in this clip, they show their image recognition prototype. Okay? So just tell me if there are any problems with the audio. So I'll play it right about now. Mhm.
이게 뭐로 보이십니까?
휴지.
그럼 이건?
컵라면.
그럼 이건?
백수?
맞다, 어머님. 방금 어머니가 한 행위를 컴퓨터가 하게 하는 것. 그게 이미지 인식입니다. 네.
그래서
보세요, 아버지. 자, 아버지, 이 카메라로 이 휴지를 찍으면 여기 토일렛 페이퍼 이렇게 인식을 하죠.
이리 줘봐. 인스턴트 누들이면 라면? 시계. 뭐 제법이네.
이게 이미지 인식을 하는 데는 많지만 저희처럼 정확한 데는 또 없거든요. 이거를 얼마나 정확하고 빠르게 인지를 해내느냐. 빠르게!
원래? 경기란 뜻이잖아.
이런 내가 왜 변기냐? 이러고 뜨면 안 되는 거잖아, 이게. 페이스! 야, 이제 되네. 다시 해봐. 무슨 의미예요? 아버님, 이게 왜? 이게 아이 이거 이거 오늘 잡았어요. 이게 조명 때문이거든요. 봐봐요. 아버지 이마가 이 조명 때문에 하얗게 전기처럼 빛나잖아요. 그래서 토일렛이라고 거예요. 이게 정식 버전은 이 오류를
Okay, so okay, so can you guys hear me? Hello?
Yes, ma'am, we can hear you.
Yes, okay, thank you. So now that we've watched that, I hope I was able to give you enough background on AI to keep you hyped. So just a few things to keep in mind. Prototypes are usually built as a proof of concept to show that it has potential and it can work. So don't worry too much if it's not perfect on your first try. So it's a starting point so you can iterate and improve upon it. So now let's break down how we can produce such application. So the first stage is planning and research. It's the project's discovery stage to point out what are the scope and limitations. So with this, you can already assess if it's feasible or not. So you can start by identifying the problem. So we'll use image recognition as our context in building our first prototype. So similar to the app they showed in Startup. So from what we've seen earlier, we're dealing with images. So this falls under computer vision. So we'll narrow it down even further by knowing what specific domain or problem are we dealing with. So this one is called the object detection problem. So there are other applications such as facial recognition, but since we just want to recognize objects in general, we'll focus on object detection. Next, we'll list down the functionalities that we want to see in this first iteration. So for us, we'll begin with the basics. So you want to detect the object first. So as you can see here, we have this green bounding box to show you where it detected an object. And of course, the recognition itself. So after detection, we want to classify the object within this bounding box. And with this example, we have a dog. So let's recap. Now that we know the specific problem we're trying to solve, we can now start looking for possible solutions to help us reach our goal. So during this step, you'll be searching for references or maybe reading related papers. So sometimes we might get too excited and immediately dive into coding. But if you do this first, you're actually minimizing the need to search for solutions midway. What you can do is to look for available datasets. So for our case, we're doing object detection. So if there are specific objects you want to support, then you can look at available datasets online like Google Dataset Search or maybe in Kaggle. So just make sure to check the license, especially if you intend to access it for research or commercial use. So if you just need to detect common objects, then you can start with something like the COCO dataset. So it's one of the more popular ones used for object detection. Then we have to look for applicable algorithms or models fit for our use case. There are overwhelming amounts of available models online, and it would be challenging to just randomly try each one if we didn't narrow it down to the specific object detection problem. So you might encounter different open source implementations. So what I usually do is to list them down and prioritize which ones to try first. So these alternatives might be useful if the others don't work as expected. Okay, to summarize, we'll simulate how to build an image recognition prototype with the main objective of detecting and recognizing objects from a video. So for the tools and libraries I will be discussing next, you can assume that these are available within Python and TensorFlow's packages. So to make things easier for you to follow, we'll use this life cycle as a guide on how we can build an AI application. So it's composed of five major stages, which include data gathering, data pre-processing, model training, testing, and finally deployment. Okay, the first stage is data gathering. So with every machine learning application, it's very important to have data. So let's say that we want to recognize specific custom objects which are not available with any datasets online. So what we'll have to do is to gather our own data. So here is one approach that you can also try. So start by recording a video. So around 3 seconds would be enough. And if you want better accuracy when detecting objects at any angle, then you should also shoot from multiple angles to appropriately get the data you need. Then we'll use OpenCV to save each frame as an image. So OpenCV is a Python library mainly used to manipulate videos and images. So from a 3-second video, we'll probably get around 100 images. And so to make sure we're organized, we'll save images for the same object in a single folder. Then we'll just name it with a corresponding classification for easy reference. So based from the video we got, at most we'll have around 100 images. But if you want to have good results, then we would need to increase that number. That's why we have to do data pre-processing. So here's a sample subset from the gathered data. So we can see images which are blurry, too dark, or some have too much contrast. So there are two ways we can work with this. First is to manually delete them based on what you think are bad quality images. Or automate it by using tools such as OpenCV and just set the parameters to know which images are too dark or too bright. And just like that, we have a clean dataset. Since you're now sure of the data's integrity, we can do augmentation. So for data augmentation, I've tried using ImageAug. It's a Python library which allows you to apply various filters on an image. So you can use it to make the images a little darker or brighter. You can also adjust from low to high contrast. or even flip and rotate the images. You can also set the number of output images after the augmentation. So for example, from the original 100 to a total of 200 images. So it's important to make your dataset as equally divided as possible to prevent biases. So the next part is to manually annotate or label the images we're going to use later on. So we'll use this image of a cat as our example. Right? So you can use data annotation tools such as label image to label your data. So for object detection, we need to use bounding boxes to indicate that there is an object within that area. So the green box here is an example of what you'll see from the tool's user interface. So just check if the whole object is inside these boundaries. And lastly, we'll just add the appropriate classification, which is a cat. So with the exported data, you'll see the corresponding bounding box coordinates. So this describes the location of the box within the image. So you have to do this task for each image in your dataset. So it might take some time, but this is a necessary step that needs to be accomplished so we can train our own model later. So after all the cleaning, augmenting, and labeling, we'll just need to split the data and we're done with this stage. Usually the ratio is 80-20 or 70-30 depending on the amount of data you have. So just make sure that your test set is unique from your training set, meaning no repeated images from each one. So what you want to check is if our model is still able to recognize an object given an image it hasn't encountered before. So as you may have noticed, data pre-processing takes up a big chunk of your time. So we need to ensure the quality and integrity of the data because model architectures need refined input to produce good performing models. Once done, that's the time we can finally proceed with model training or development. So for this, we can use TensorFlow Object Detection API. So this is built on top of TensorFlow to streamline object detection tasks. It allows you to easily integrate training and deploying models in your pipelines with less code. So later we'll also look into compatible pre-trained models for this framework. So to train using this API, it only accepts a specific data format for it to work. So in this step, you need to convert the datasets into TensorFlow optimized format. To be more specific, we need to convert it into a TF record. So what this does is basically converting your data into binary storage format. So this also comes in handy if you're dealing with large datasets that cannot be fully stored in memory. So after we're done with converting both train and test datasets to TF records, we can now train our own neural network model. First, we'll load a model from the TF2 object detection model zoo on GitHub. So from here, you can browse through a collection of pre-trained models which are compatible with the API. So you'll see something like this. So this is a sample from the table you'll see in GitHub. So speed